Microwaves are basically magic. Think about it. A metal box that heats up your food with invisible waves, and we just act like that's totally normal. I get it. In a world of Italian brain rot and Mr. Beast challenges, we barely have time to blink, let alone question our kitchen appliances. But let's hit pause for a second and actually ask, how does a microwave even work? To get there, we need a quick crash course on electromagnetic waves, specifically microwaves. And yes, microwaves aren't just the oven in your kitchen. They're actually a whole class of waves within the electromagnetic family. Think of electromagnetic waves as the Swiss Army knife of the universe. They come in all shapes and sizes, from tiny high-energy gamma rays that can slice through atoms, to giant, lazy radio waves that stretch longer than a football field. Visible light, the narrow band your eyes can actually detect, sits near the center of the electromagnetic spectrum. Further down the line, with longer wavelengths and lower energy, are microwaves, the overlooked middle child of the spectrum. They're not as intense and scary as X-rays, not as chill as radio waves, but with just the right amount of energy to get the job done without setting your kitchen on fire. Now that we know what microwaves are, let's talk about how they ended up heating your leftovers. Well, it all started with this guy, Percy Spencer. Back in 1945, while working as an engineer at Raytheon, Spencer was messing around with a magnetron. No, not Megatron. That's a giant robot with daddy issues. The magnetron, on the other hand, is the heart and soul of every microwave. And honestly, it's pretty cool. Picture the magnetron like a high-tech whistle. It uses a heated filament, called a cathode, to release a stream of electrons. These electrons get whipped into a tight spiral by a powerful magnetic field inside a vacuum tube, creating a high-frequency electromagnetic field that pumps out microwaves. Specifically, these waves oscillate at around 2.45 gigahertz, which means the electric field flips direction about 2.45 billion times per second. That's about 245 million times faster than you blink. Anyway, one day Spencer noticed that a chocolate bar in his pocket had melted while he was standing near a magnetron. Most people would just curse their ruined pants and move on, but Spencer had the presence of mind to think, wait a minute, what just happened here? So he grabbed some popcorn, zapped it with microwaves, and when it popped, he knew he was onto something more than just a sticky pocket, and he was right. When these microwaves interact with water, fat, and sugar molecules, they start heating them up. Why just those? It's all about polarity. Water, for example, is a polar molecule, meaning it has a slight positive charge on one end and a slight negative charge on the other, kind of like a tiny magnet. When exposed to the rapidly oscillating electromagnetic field, these polar molecules start flipping back and forth, trying to keep up with the changing field. This frantic molecular dance creates friction, and friction creates heat. So yeah, every time you hit start, your food gets thrown into a molecular rave, bouncing to an invisible beat until it's hot. And that's the reason why the frequency is exactly at 2.45 gigahertz. It's the sweet spot for water molecules to start moving in sync, just like on the dance floor when they put on your favorite music. Now you might be wondering why I said in the thumbnail that ice doesn't melt in the microwave. Sounds like clickbait, but it's kind of true. Here's the twist. Ice is water, but frozen water molecules are locked in a rigid structure. They can't wiggle, flip, or dance like they do in liquid form. So when the microwaves show up, the ice just sits there. No movement, no friction, no heat. Only once some of the ice melts into liquid water does the real heating begin. And that's why it takes longer than you'd expect. The first commercial microwave oven, the Radarange, was a beast, weighing over 700 pounds and costing around $5,000 in today's money. Unless you had a warehouse and a trust fund, microwaving was for the future. Thankfully, those giant dynos have slimmed down to the sleek countertop companions we know today. But is it even safe to stand near one of these things? Well, microwaves are designed to keep their high-energy waves safely contained, but if the door seal is damaged or the unit is faulty, a small amount of radiation can leak out. While this probably won't turn you into a superhero, long-term exposure to high levels of microwave radiation can cause tissue damage or burns, since it heats up water molecules. And guess what you're mostly made of? So, it's a good idea to give your microwave a little personal space while it throws its molecular party. In the meantime, sit back, relax, and keep scrolling through those TikTok memes.